Okay, Bismillahirrahmanirrahim. We're going to start a P4 today. It is from June 2019, paper 4-2. First question, this is on resolving forces. It says coplanar forces of magnitudes 40, 32, P, and 17 act at a point in the directions shown. The system is in equilibrium, so you need to underline this thing. The system is in equilibrium, so that means like the resultant is zero. When the resultant is zero, that means your Rx is zero, and then your Ry will also be zero. So that is what we have when we have the forces in equilibrium. Okay. Okay. So we have to find the um, this P and theta. Okay, so guys, we'll be starting by resolving all these forces. First of all, you see that I'll be resolving this force of 32 newtons. You can start with any one of these forces. So this is going to be 32 cos 20, and this one is going to be 32 sine 20. Okay, and I'll be resolving this force like this. Um, this one is 17. Let me write this clearly. This is 17, and I need to have this angle inside here. So this is going to be 35 degrees. Okay. If I wanted, I could have resolved it like this in this direction as well. Okay. So anyhow, this is 17 cos 35, and this one is going to be 17 sine 35. Okay. And then I'll be resolving this force because there is some overlapping. So I might have some overlapping. So I'm just going to put this angle theta over here. Okay. So this force is going to be P sine theta, and this is going to be P cos theta. So we have resolved all the forces. Okay. So now I can say, okay, my Rx is going to be, first of all, this is 32 cos 20. Then I have minus 17 cos 35. Okay. And then I have minus P cos theta. And that is going to be equal to 0. We have already established that Rx and Ry, they are going to be 0. So this gives me P cos theta equals 17 cos 35 minus 32 cos 20. Someone please find this value and tell me. In the meanwhile, I write the vertical components resultant here. Okay, for the vertical components, this Ry is going to be, I'm taking upward as positive here. So I have 40 degrees upward, then I have plus 17 sine 35. Okay, then I have two forces downwards. One is 32 sine 20, and then I have minus P sine theta, and all of this is going to be equal to 0. So we have from here P sine theta equal to this 32 sine 20 minus 17 sine 35, and then I have minus 40. I wonder why did I put this degree sign on it? So there's no degree sign on this 40. So please, if someone has the calculator, tell me what is this P sine theta, and you should give me correct to like 2-3 decimal places, because these are not the final answers here. Okay. So what is this P cos theta? Did anyone find this P cos theta? Minus? Uh, exactly minus 16? Minus 16.145. And this P sine theta? Exactly 38.8? 38.8061. Okay, thank you. Beta, please, I'm afraid you might get 1 mark deducted over here, okay? So you people have this, these are not your final answers, okay? It's an ideal thing if you keep them in exact form. Like since we can't have that, so try to write them correct to at least 4 decimal places, okay? Now, guys, we have to find the values of the theta and then this p. So how can I find theta and p? Yeah, so we know that we will solve them simultaneously. So how would you do that? Yeah, we should divide them side by side. Good. So dividing them side by side, I have this P sine theta over P cos theta, that is equal to 38.8061 over this minus 16.145. So the p's cancel with the p, okay? And this is, acha, before you do that, I forgot to, yeah, you see we are doing this after so many months here. So you see that this Rx is negative and Ry is positive. So you can, huh? What? This is minus 38? Oh, no one told me. Oh, thank you for this, Mariam. So you see, because of these two components, you can have an idea that in which direction do you have, like, these going, okay? So this P cos theta, and then you have P sine theta. Uh, just a minute, let me, oh, theta is over here. I'm already clear that in which direction that is going. I think we do that for the resultant when you have Rx and Ry, then you can visualize that in which quadrant, which direction it is going. So this is going to be cancelled with this. So tan theta is going to be equal to something. And what is going to be this theta now? Tan inverse of this, huh? 67.4 degrees, correct to 1 decimal place, okay? So you put this theta into any one of these two, so you get your P equal to what? 42.0, okay, zero point 0 newtons. So that is your P and this is your theta. Should we check the answers? Yes, I have the this 67.4. Okay, so our answers are exactly matching. Okay, that's great. So let's move on to the second question. Okay, moving to the second question. Okay, time for you to try this first. Okay, a car moves in a straight line with initial speed u and constant acceleration a. Okay, so I can have a rough sketch here. So this is how the car is moving, and here is the initial speed u meter per seconds, and its acceleration is constant, which is a meter per second square. So this looks to be the question from Kinematics 1, where we use those Newton's equation of motion, which is also called SWAT, okay? So the car takes 5 seconds to travel first 80 meters. So let's say this is the point A and here is the point B, and these are the distance covered over here is 80 meters and the time taken is 5 seconds. And it says it takes 8 seconds to travel the first 160 meters. So let me have the point C over here. So this means BC is another 80 meters here, and the time taken for this is going to be 3 seconds. Or you can also say that the distance AC has been 160 meters, okay? And the time taken for this is going to be 8 seconds. Okay, so we have to find the value of A and U. Once again, your algebra will be tested over here, and you need to recall that the equations that we have learned before. So the equations that we have, one is V is equal to U plus AT. The other one is S is equal to UT plus half AT square. And then you have 2AS that is equal to V square minus U square. So we have to see that which equation fits in here. So from this first information, I think I can use this equation here. So from this AB part, I can say that this AT is equal to 5U and then plus half into uh, A is times this 25, है ना? So we have this 80 is equal to 5U plus 12.5A. That is my equation number one. I think we should consider the segment AC for the second equation exactly in the same way. So for the second part, we can say this 160 is equal to, the time taken is 8 seconds. So that is 8U and half into the time is, so the acceleration is A and the time is again 8. So its square is going to be 64. So you have 160 equals 8U plus 32A. So that is your second equation. You must be able to solve these two equations simultaneously and you must get your U and A. Yeah? Because the acceleration is constant throughout. So nothing has changed. Okay. So that is why you can do that. So after you solve them simultaneously, these are the answers that you must be getting. This is, I believe these are two linear simultaneous equations. Okay. So you can solve them easily. So I'll be moving to the next question now. So here we are with the third question. Give it a try and then I'll be trying, inshallah. So here we are with the third question, guys. It says a particle of mass 13 kg is on a rough plane inclined at an angle of theta to the horizontal where tan theta is 5 by 12. Okay. So I need to draw a diagram here. So this is my inclined plane here. And this is my theta over here. Now, I have been given that this tan theta is 5 by 12. Now, don't try to find the value of theta from here. You just draw a right angle triangle, okay, like this. This is your 5, this is your 12, this is your theta. And through the Pythagoras, you have this hypotenuse that is 13. So from here, you can have your sine theta that is going to be 5 by 13 and your cos theta is going to be 12 by 13 because you will be using the values of sine theta and cos theta. Okay. So we have this ready. Now here is this particle. Let me put it here. Okay. Now this has a mass of 13 kg. So I'll be showing its weight down here. That is 130 newtons. Okay. And I'll be resolving this weight parallel and perpendicular to this inclined surface over here. Do you remember this typical diagram? Okay. So I'll be resolving it like this. And here you will have this R upward, okay, the normal contact force. Okay, if this is theta, so this is going to be theta as well here. So now this is going to be 130 cos theta. This one is going to be 130 sine theta. Okay. The coefficient of friction between the particle and the plane is 0.3. So we have been given the mu as 0.3. A force of magnitude of T Newton acting parallel to this greater slope moves the particle a distance of 2.5 meter up the plane at a constant speed. Okay. So here is a force which is T newtons over here. This has moved this up the plane here. It has taken this. Let me call this point over here A and here is the point B. And this has gone up a distance 2.5 meters. Yeah, 2.5 meters. Okay. And it says For, like with all this given information, it says find the work done by this force. So we have to find the work done by this force tension. Thank you. So now there are many ways of attempting this, but I think the easiest way is just to find the value of this t, okay? And you multiply that with 2.5 because you know that would be the work done by this t would be t times this 2.5. Work done is the work is going to be F into S. Okay, we're going to use this formula here. Okay, so I have seen here the speed is constant. You can see that the speed is constant over here. So that would mean that this t is going to be equal to this downward component of weight and plus this frictional force over here. Let me put that, keep that as x over here, okay? So let us calculate this x first of all. X is going to be equal to mu r, okay? And your mu is zero point 0.3 and your r is going to be 130 cos theta. 130 cos theta is 12 over 13. So I think that is 36 newtons. Yes. So you see that is how you get this in exact form, 36 newtons. So now, if you people allow me, I can write this T equal to, this T can be written equal to this x, which is 36 plus this 130 sine theta. Am I right, guys? Anna? So this t is going to be 36 plus 130 times sine theta is going to be 5 by 13. So this is 50 and 36. That is going to be 86. Yes. So T is 86 newtons, and we reach to the answer that this work done by the driving force or this tension in the whatever that force is. So that is going to be 86 times 2.5. And how much is this? 250? 215 joules. Okay, remember to use the right units here. That is the work done by this T. Okay, so you see there were 5 marks for this. Is there any question? So we are going to move on to the next question, guys. If there is no question to be asked, question number 4. So you guys give a try to it. Look at this. This is a 7 marks question. A constant resistance to motion of magnitude 350 Newton acts on a car of mass 1250 kg. The engine of, okay, a constant resistance to motion of magnitude x on a car of mass 1250. The engine of the car exerts a constant driving force, okay? Now there is a constant resisting force, there is a constant driving force, okay? So we need to underline this, there is a constant resistance, okay? And then there is a constant driving force. So we keep on highlighting the important information here. The car travels along a road inclined at an angle theta, okay? So the road is inclined where sine theta is 0.05. Find the speed of the car. We will find the speed of the car when it has moved 100 meters from rest. In each of the following cases, the car is moving up the hill. Okay, so let's call this the first part. Now, here is that hill. Okay, and this is inclined at an angle theta. Okay, so we have been given that sine theta is going to be 0.05. Now here is a car. The mass of the car is 1250. So let me show this mass here. That is 12,500 newtons. So we resolve this like this. Okay, this is theta here. This is going to be 12,500 cos theta This is 12,500 sine theta, and here is your R. Okay. Now it says the car is moving up the hill. So I'll have my driving force up here, which is going to be 1200 newtons. This is 1200 newtons. And there is a constant resistance over here. So I'm going to show that downwards, that is 350 newtons. Okay. Acha. So we have to find the speed. Okay, we have to find the speed when it has moved 100 meters from rest. So it means u is 0. So this speed is basically that we have to find is going to be v then. Okay, we have to find v when it has started from rest and it has covered a distance of 100 meters. Okay, in the following cases. Acha. Now, it says the constant resistance to the motion is 350 newtons. So do we need to calculate R and then see okay, what is that frictional force? I think that is given to us. Like, after considering this R and all that coefficient of friction. So we need to have the acceleration over here so that you can find V over here. So that is our favorite formula to be used here. Finally, it came into action. That is F equal to MA over here. Okay. So F equal to MA. So this is going to be 1200. That is the upward force. And there are two downward forces. One is 350 and the other is going to be 12,500 sine theta. That is 0.05. Okay. And that is equal to 1250 times A. Okay. Now please solve all this equation and tell me what is your A. Okay, so this A is exactly 0.18. Okay, but thank you. 0.18 meters per second square. So once we have that, so we have got this acceleration here. Which is 0.18 meter per second square. So which equation we are going to use? 2as equal to v square minus u square. So let's use that equation here. So this is 2as. I should be working under this, but since there's no space over here, so I'm putting this at the top. So when you're attempting a paper, please go in a sequence, okay? Don't mess up the work like I am doing here. This really annoys the examiner. Okay, 2as, it is going to be v square minus u square. This is 2 into 0.18 into the distance, which is 100. V has to be calculated and u is already 0. I'm not writing that. So is that 6? Okay. So this is 6 meters per second. So that is the first case when it was moving up the hill. Okay. And then it says when the car is moving down the hill. Okay. We have just 2 minutes to do that. So when it is moving down the hill, so I'm going to make some changes here. You see that this 1200 would be now acting down. Okay. So this is going to be 1200 newtons acting downward. I've started doing the second part, guys. Okay. And this 350 would be now acting in the opposite direction. Okay. 350. And while you're going to calculate the acceleration, this equation would be changed now. Okay. Let me change this equation here. So this will be 1200 plus 12,500 into 0.05 minus 350. Okay. So what is the acceleration this time? 1.18. You see, acceleration has increased because it's moving down. Okay. So you put that acceleration here. Now the acceleration is going to be 1.18 meter per second square. Okay. So you put it here, 1.18 here. So what is the speed now? 15.3. This is 15.3, okay? So the new speed is going to be 15.3 meters per second. So we have managed to complete. Achha, by the way, when you will be doing this in the exam, you have to draw this diagram again, okay? Or at least like, don't do that overwriting that I have done over here, okay? Okay, guys, we move to the question number 5 in our next segment, okay? Okay, the fifth question, two particles A and B of masses 0.4 kg and 0.2 kg respectively are connected by a light inextensible string which passes over a fixed smooth pulley. Both A and B are 0.5 meter above the ground. The particles hang vertically, the particles are released from rest. So this means the initial speed is going to be 0 here, okay, and it says in subsequent motion B does not, the particles hang vertically. It says then um, in the subsequent motion, B does not reach the pulley and A remains at rest after reaching the ground, okay? So this A is going to go downward, okay? And it reaches the ground and B does not reach the pulley, okay? So B would be going upward here, okay? So for the motion before A reaches the ground, okay, like they are in motion, okay, A hasn't reached the ground, show that the magnitude of the acceleration of each particle is this. Find the tension in the string. Now, this is a very, very typical question over here, okay, where you have two simultaneous equations. Now, the first thing is that both of these strings, they will have the tension upward here. This is the tension, this is the tension, and the tension would be the same because it's just one string over here, okay? The tension is same. So I have to show the weights here. So this has the weight downward, which is going to be 4 Newton here, and here is the weight downward, which is going to be 2 Newtons here. Now, this is one of the easiest questions that you can have on the connected particles, because you typically have two equations here. Particle A is going downward. So using F equal to ma, you say, okay, this is going to be 4 minus t. That is from the particle A. 4 minus t, that is equal to 0.4 A. Okay. And from the particle B, this is going upward. So the upward force is T and the downward force is 2. And that is equal to 0.2 A. So these are the two equations. You solve them simultaneously. You will get both the acceleration and the tension here. So if I add them together, this is 4 minus T equal to 0.4 A. Let me write this T under the T. And this is minus 2 and this is 0.2 A. So you have 2 equals 0.6 A, and your A is going to be 2 over 0.6, which is 20 over 6, and that is going to be 10 over 3. That is what you have to show, that this is 10 over 3 meter per second square. Okay, and then you put that acceleration in any of these equations. This is going to be T is equal to 0.2 into 10 over 3 and then plus 2. Okay, so this is 26 over 3. Yes, okay, 26 over 3, that is 8 whole 2 by 3 newtons. So that is the first part over here. Okay, now yes, madam. Okay, there is some silly mistake here. This is going to be 8 over 3 here, okay? So this is 2 whole 2 over 3. Okay, so now we move on to the second part here. In the second part, it says, find the maximum height of B above the ground. This is again another typical question. The maximum height of B above the ground. So I'll be going back to this diagram here. The maximum height of B above the ground. So let's see how to do that. I'll have to clear all of this, okay? So we have the acceleration there, okay? The maximum height of B above the ground, that is what we have to find, okay? Now guys, see, this A will go down here and it will hit the ground, okay? And it is not going to bounce back, okay? Now this B is going to go up here. Uh, when it has covered this A 0.5 meters, this B would have also covered 0.5 meters while moving upwards, vertically upwards, okay? Now, you have to imagine, guys, that what will happen at the moment when A would be hitting the ground? What will be happening to this particle B? Will that immediately stop, or it would go a bit higher than this point over here because of its momentum? It will go a bit higher, okay? So you can divide this B's motion into two parts. One, when the string is taut, and second, when the string is slack, okay? When the string is taut, the tension is the force that is making it move upwards, okay? And when the string is slack, it would be moving under gravity. It would be moving under gravity. And one more thing, when the string is taut, the particle B is being accelerated upwards. And when the string is slack, while moving upwards, it will be decelerating. It will be decelerating. And its deceleration would be equal to G. That would be equal to G. Okay, so now let's divide this movement into two parts. So we know that as long as this particle was, this string was taut, it has covered 0.5 meters. Okay. Now we have to find the distance that it covers while the string was slack and the particle was moving upwards. Okay. Now imagine this is the situation from, let me say, from X to Y. This is moving upwards when the string is slack. When it reaches the point Y, you know that at this point, its final speed would be 0, okay? And while it is moving upward under gravity, its upward acceleration is going to be minus 10 meters per second square. You have to find the distance. You can do that if you find that what is the speed at this point X. So guys, we have to find the speed at this moment. The speed the speed for the interval when the string is slack is going to be the final speed over here. The initial speed for this XY is going to be the final speed over here, okay? So let's find that final speed. You know that here its initial speed is 0, the distance covered is 0.5, the acceleration has already been calculated, which is going to be 10 by 3. So let's find the final speed over here. What equation I'll be using here? 2as, because this is your distance that we already know. So this is 2as, that is v square minus u square. We have 2 into 10 by 3 into half, and final speed is 0. Sorry, final speed we have to find, sorry. And initial speed is 0. So this v square is going to be 10 by 3. Let's not find the square root, okay? Because this will be again using it here. So now I'm going to write that this u is going to be under root 10 by 3. So let's use this again and find its distance while moving upwards. So this is going to be 2as, that is going to be v square minus u square, okay? So this is 2 into minus 10 into s has to be calculated. V square is going to be 0, u square is going to be 10 by 3. Okay, so this s is going to be 1 by 6. If I'm not wrong, this is 1 by 6, okay? So he was asking us to find the maximum height above the ground. Yeah, the maximum height of B above the ground, okay? So this maximum height is going to be, first of all, this 0.5, don't ignore this 0.5, another 0.5 over here, okay? And then that 1 by 6. So this is 0.5 plus 0.5 plus 1 by 6. That is 1 whole 1 by 6 meters. Okay. And I should check the answer now. Okay, question number 6 from the same paper, which is of June 19, variant 42. It says a car has mass 1000 kg. When car is traveling at a steady speed of V, where V is more than 2, the resistance to motion of the car is AV plus B. Now remember, this is the resistance to the motion of the car whenever the car is moving at the constant speed, okay? The car can travel along a horizontal road at a steady speed of 18 meters per second. So here is a car going on a horizontal road. This is my car, okay? This is going at a speed of 18 meter per second. When the engine is working at 36 kilowatt, like the power over here, we have the power which is going to be 36. Okay, let me enter these people here. Okay, so the power over here is 36,000 watts. Okay, the car can travel up a hill. Now here is a hill which is inclined at theta, and we're given that sine theta is sine theta is 0.05. Okay, it says the car can travel up a hill inclined at this at a steady speed of 12 meters per second. So if the car is going up the hill, its steady speed is 12 meter per second. When its engine is working at 21, so here the engine has the power 21,000 watts. We have to find A and B. Okay, so guys, if you pick this word steady speed, I think you can solve this question. Steady speed. What happens when an object is moving at a steady speed? What can you say about the resultant of the forces on that object which is moving at a steady speed? The acceleration is zero, the resultant is like, zero, and the forward forces would be equal to the backward forces. And like, in both the cases, we can say that, okay, backward force over here is going to be AV plus B. That is the backward force. And here the backward force is the same, which is AV plus B, okay? But the only difference over here would be that you will have to show the weight downward, which is going to be 10,000, okay? And you will have to resolve this weight, okay? And this component would be needed here. We don't need this because we are not interested in finding the normal contact force. So this component, which is parallel to this inclined plane over here, that is going to be 10,000 times 0.05. Okay, this is 0.05, that is sine theta over here. Okay, so guys, let's solve this now. So for this, you see there are two unknowns, A and B have to be calculated. So there is always a hint coming in your mind that we might have two equations and then we'll have to solve those two equations simultaneously. Okay, so two equations that we have to have, and then the steady speed is telling us that the forward force is going to be equal to the backward force. When you have the speed over here and you have the power, you can always find the driving force, okay? You have the formula, power is going to be the driving force times the speed, okay? And this is going to give you the forward force while going on a straight horizontal road. So this is 36,000 divided by the speed, which is 18. So the forward force over here is going to be 2000 newtons, okay? And you have the equation here. If you put the V, which is 18 over here, so can I say that this backward force, which is going to be 18A plus B, that will be equal to the forward force, which is going to be 2000. Okay, so this is your equation number 1. Okay, now we come on to the second part over here. The forward force over here, let's calculate that. This is going to be again using the same formula over here. So this forward force in this inclined case is going to be 21,000 divided by the speed, which is 12. So what do you get? I think that is 1750. Can you divide? Yeah, this is 1750 newtons. Okay. So we have the forward force 1750. And this time your equation would be, I'll be writing it here, 12A plus B, and then plus, this is 10,000 into, is that 500? Yeah, this is 500, and that is equal to 1750. So this 12A plus B is going to be equal to 1250. So guys, these are the two equations. Please solve them simultaneously and tell me what do you get. What are the values of your A and B? So you have your A and B. After solving them simultaneously, please tell me what do you get. Yes. A, just a minute, let me write it down. A is 125 and B is, so when you solve these two very easy peasy lemon squeezy equations simultaneously, you get these two values, the required values of A and B. Okay, the time to move to the next question. I have to clear this. We move on to question number 7. So you give it a try first and then I'll be doing it. Okay, seventh question, particles P and Q leave a fixed point A. So they're both starting from the same point, okay? So at the same time and travel in the same straight line, the velocity of P after t seconds is, so this is the velocity of P, that is 6t into t minus 3, okay? And the velocity of Q is 10 minus 2t. Sketch on the same axis the velocity time graphs for P and Q for the time 0 to 5. Okay, so guys, you see that in your P1, you guys have studied a whole chapter on quadratics, okay? So you should be a player of that. So one thing is quite clear when I have to sketch, you see we have to see the x-intercepts, the y-intercepts, and ideally if you have the turning point as well, okay? So if you put that equal to 0 over here, this 6t into t minus 3 equal to 0, you have the intercepts, the horizontal intercepts, which are going to be 0 and 3, okay? And you see its turning point would be at the midpoint of these two. So when the time is 1.5, it will have its turning point, है ना? So because because of that symmetry concept here. So you put this t as 1.5. Please tell me what do you get when you put this t as 1.5? Minus 1.5. Don't tell me this is minus. Yes, this is, yeah, this is minus 1 point. Minus 30. Okay, this is minus 13.5. Okay, yeah, that was 9 into minus 1.5, hai na? So yeah, that is right. Okay, so guys, this means this graph is going to be something like like this. Okay, so when the time is 0, it is here. When the time is 3, it is here. And when the time is 1.5, the speed over here is minus 13.5. Okay. Now we have to sketch the second. That is again an easier thing to draw. That is a line graph here. So when the time is 0, it is going to be at 10, maybe here. Let me draw this blue with blue. This is 10. And when you put this V0, it is going to be at 5. Hai na? So this is going to be passed from this 5 like this. I can use this line option here. So this would be a line like this. Okay, so these are the sketches of the velocity time graphs of both P and Q for 0 to 5. And I think I should mention here, because he's asking for 0 to 5, we should show that what would be its speed when the time is 5. So I'm sorry for ignoring this thing here. So I have to show that. So when you put T as 5 here, so this is 30 into 2, that is going to be 60, Hannah. So this is going to be 60. So this point over here is 5 comma 60. Am I right, Mitchell? Because I'm doing this mentally. Okay. Is that right? Okay. So these are the two sketches here. Now next it says, let's go to the second part. Verify that P and Q meet after 5 seconds. How would you verify that P and Q meet after 5 seconds? So that means they are going to be at the same point when the time is 5 seconds. Hai na? Okay, if you go back to the statement here, it says verify that P and Q meet after 5 seconds. So basically, you have to imagine that they started, let me make this clear here. They started from the same point, okay? And suppose they started from here, and this is the direction in which they are supposed to go, okay? So let me call this point, have they given us any starting point here? Yeah, the fixed point A. This started from the fixed point A. So guys, you have to realize that this P is going in an opposite direction. Like, you know, this is the direction of the P, initial direction of P, and this is the initial direction of Q. Because for the first 3 seconds, the P's velocity time graph is below the time axis, and the Q's velocity time graph is above the time axis. So that means they are moving in opposite directions. Okay, so we have to see that how much distance this has covered, this P, while moving away from the point A. So for that purpose, you will have to integrate this for the limits from 0 to 3. Okay. And if you don't put a minus here, because this is going to be the area under the time axis, so you will be getting the answer in minus, and I want you to see that. Okay, this is 6t square minus 18t dt. So this will be, when you integrate this, you will be getting 60 cube over 3, that is 2t cube, okay, and minus 9t square. This is what you get after integration. The limits are from 0 to 3. When you put the limits here, you get minus 27. You see that this is minus 27. That is a displacement that is moving away from this A. So this has reached here when the time is, let's say it reaches the point B, and this distance is 27 meters over here. Okay. And then we have to see that how much distance it covers from 3 to 5. Okay, or what is its location from 3 to 5. So you will apply the same limits. We have already integrated it, or you can say, okay, this is going to be from 3 to 5. So this is going to be the same 6t square minus 18t. We want to see that where does it land after 5 seconds. So this is going to be 3 to 5, and the same integral 2t cube minus 9t square. So when I put the limits here, I get this equal to 52. That is going to be 52. Okay, so this means from this point, it has gone to this direction, a distance of 52 meters. So let's say it is here at the point C, and this means this distance AC is going to be 25 meters. AC is 25 meters. So if they have to meet at 5 seconds, So this means this particle Q should also have covered this distance 25. So now, I'm sorry, I'm going to use this area over here to show that, okay? So for this particle Q, this would be limit from 0 to T, okay? Or limit from 0 to 5. And this is 10 minus 2T dt. Now this should be equal to 25. This should be equal to 25 if they are meeting when the time is 5. Okay. So you see that this is going to be 10t minus t square limit from 0 to 5, and that is equal to 25 meters. So this has been verified that that both the particles meet when the time is 5 seconds. Okay. So the last part, in the last part, it says, where is the last part? Find the greatest distance between P and Q for the interval 0 to 5. Okay, I'll have to erase some information from here. In fact, I need this. Okay, I'll be needing this expression here. Okay, and I just want, like, we had a mental brainstorming here and we thought that this would be the time 3 when this happens, because when the time is 3, this P is like, instantaneously at rest. It is moving backwards. But anyhow, we have to have the expressions for this. So between P and Q. So this is going to be, this is 2t cube minus 9t squared. What do we have here? This is 9. Just a minute. Hold on. So 2t cube minus 9t square. What was the integral of that? 10t minus t square. So minus 10t, this is plus t square. Hai na? So let's simplify this. Let me keep this as s over here because I have to differentiate this. So d se zara confusing ho jayega. So this is 2t cube, and people are still entering yard here. Okay, so 2t cube, and I have minus 8t square minus 10t. Okay, so we have to find the greatest. Whenever you have the greatest or the smallest thing to be calculated, you should have the calculus in your mind that you have to find the stationary point, okay, that turning point. So let's find this ds by dt and put that equal to 0. This is 6t square minus 16t minus 10 equal to 0. So please tell me, what do you get for this? So this is 3.19 and minus 0.5. So we'll be ignoring this minus value. So this is the time 3.19 seconds when they are furthest away from each other. I think that ends the paper. Is it so? Yes. So congratulations, beta. We have completed this paper of June 19 variant 4.2. Thank you very much.